Everybody, it's Tyler here at the Score Signature event, checking in 3796F. This team pay respects this team. They have been on a tear this season so far. Already a couple event wins, multiple robot skills, and excellence awards. Shoes, and congratulations on all your success that you've had so far. This robot rocks. I just watched them in the last match that they played early on here at the competition, and just a very complete package. 600 RPM drivetrain that we'll be diving more into. Some cool custom stuff they're doing with their gear, so make sure you pay attention to that. We'll be doing also then an overview of just everything that's gone into this, some of the modifications they made throughout the season as well too, and they're looking really good here for high stakes. Let's learn more about them coming up here on Pits and Parts. Brock, let's start off talking about this 600 RPM drive base on here. I love to kind of dive more into it, and you were telling me earlier you did some cool stuff with your gears as well.
Yeah, absolutely. So we are running a 600 RPM drive. We have we're running 6-motor drive. Each of these motors is connected to a shaved 48-tooth gear, so I shaved these in half so we can have a small drive base. This gives us a lower profile for the field, but I shaved it so much that we can actually fit in this small gap. Here on the sides, instead of doing the standard screws, we wanted to save a little bit of weight because of the bearings. They're strong enough with these zip ties right here. We don't really need those screws. It allows it to kind of move. If the robot gets hit or anything, the axles are able to shift. We found that better than just hard mounting it.
So running a 600 RPM drive, did you have to give up anything in order to divert so much power to your drive?
Yeah, absolutely. So for the last 2 years, we've been running consistent 450 2.75-inch wheels drive bases. We love this drive base. I drove it at Worlds and beginning of this year, but we wanted more speed, especially for skills. We felt like we were lacking in that, and we felt that with a little bit of loss of power but more speed, that we could make up for it through the speed.
Jacob, let's talk about your intake and clamp, kind of follow that initial journey of the rings. Anything else you might want to cover on your bot?
Yeah, so previously on our past 2 robots for the season, this is our 3rd robot of the season, we have ran what we call a full motor intake. So basically we are just using one 11-watt motor to power both stages of our intake. So we power our top stage, our conveyor belt, by this motor, and then we would put a gearbox off to the side and chain it down to our lower stage. One thing we found with this is sometimes in Auton, or it could jam itself, or maybe if we were trying to go under the bar while spinning our intake, our hooks would hit, and something like that would throw off our Auton. Also in driver, for things like Lady Brown, it's easier to hold a ring down here and still spin this, so we don't have to raise our Lady Brown up and risk it falling out. So we can just have our Lady Brown in loading position, have one ring in the Lady Brown, and then we can just hold another one down here in our bottom stage. So our bottom stage is powered by a 5.5-watt motor. We torque this up, we speed this up to 400 RPM, which you contact with our flex wheels down here. Then we bring that up onto our Delwyn ramp, of course. Then that is transferred onto our conveyor belt system, which is spinning at 600 RPM. That then scores with that onto our mobile goal. So we clamp our goal just with 2 pistons powering this 1 3x, and so we put these pieces of Delwyn here. So one thing that, as Brock was talking about earlier with our 600 RPM drive base, we wanted to make it as narrow as possible so it's lighter. And so one thing I had to sacrifice this was, unclamp real fast, that sometimes the goal will twist when it goes inside the clamp. So what we did to fix this was we added these 2 little Delwyn triangles and clamp again. And what happens is whenever it goes in, this means that the mobile goal can't twist left and right, so we always get a consistent score. Unclamp. Another thing that we added was these 2 zip ties, because a problem that we experienced was our goal would overclamp and maybe get caught in the hooks. So these 2 zip ties almost act as like a hard stop. So whenever we clamp the goal, it can't bend up anymore. And so then we use our flex wheels up here at the top just to give us that better flip, and then we can use that. It makes scoring on the align stake much easier.
Is your team doing any sort of color sensing or anything like that?
Yeah, we are doing color sense, but I'll let Roosh talk about that.
So one thing that we noticed at our previous 2 comps is that during match, we didn't want to be able to intake the opposite color ring. So right here on the robot, we have an optical sensor that sits very narrowly inside this intake. So we do this just to save weight, or not to save weight, but we do this to keep it small. So then as soon as the color sensor detects the ring, it'll stop the intake briefly, and then the following momentum from the ring will just carry on, and the ring will fling off instead of flipping onto the goal. This is very useful during our matches, as Jacob doesn't have to outtake and can instead just intake it, flip the ring off, and get over to scoring wall stakes and going positive corners a lot faster.
Since we have you, anyways, what other sensors might you want to highlight on your robot?
So on our Lady Brown right here, we have a rotation sensor. So since we're using a 5.5 watt motor instead of 11 watt, there is no motor encoders, so we can't use those for a Lady Brown. So this rotation sensor is what gets the values for our Lady Brown, so it's accurate every single time going up to loading position. So I can show you. All right. Other than that, we also have on the bottom of a robot this rotation sensor right here for our odometry wheel. So for the odom, we wanted to have just a horizontal odom as we didn't have enough space for a vertical, and this is because on 600 RPM drive, you tend to drift a lot when you're stopping or turning. So having just a horizontal odom wheel to stop our horizontal drift is very useful and very nice for our skills and all of our autons.
I was going to ask you, is there anything else in skills in particular that you implement from this robot that might be different than in an actual match?
One thing actually is we use our Lady Brown to score on the align stick instead of the standard intake during auton. So we do this because since the robot has to be very accurate when it has to score with the align stick, using the Lady Brown gives us a little bit more wiggle room as it can sometimes funnel the robot closer into the align stick. So we just send this up, put a ring in there, and then we just flip it over onto the goal. This actually speeds up our auton a lot faster, so we don't have to move the goal on the opposite side of the field out of the way. We can clamp that goal, score the align stick with Lady Brown, and then get on with the rest of our skills path.
Levi, let's talk more about the Lady Brown mech on there. Any big like modifications that your team has maybe made to Lady Brown, or any testing that you've done with that? And I also noticed you do have a doinker if you want to cover anything on that too.
A Lady Brown is run on it was run on two 5.5 watt motors, but now we switch over one, as Jacob was saying, so we can have split motor intake. The motor spins at 200 RPM. It is on a torque ratio down to 50 RPM. Even though 50 RPM doesn't sound like a lot, I mean, you can see it in match. Jacob is very fast at scoring the wall sticks. We also use the Lady Brown to untip or tip goals, like in match. So you go like, well. Okay, well, in match, of course, it would work. And this helps when you're trying to get a mogo out of the corner. You can kind of reach around the person almost and try to get it out of the corner, especially in negative things in the last 30 seconds.
Has your team looked at doing anything in regards to like untipping goals at all?
Yes, so like we also use this, so we can go like that and just like that. And I mean, we've proven this has been very useful with the design of our Delwyn, but also just testing and making it just testing.
Cool. Anything from your doinker you want to add?
Yeah, so we use our doinker in rush autons, so we can grab the goal and take it, because normally people just go with the back of the robots, and this helps us get the goal before they can. Also, we use this to clear out the full rings in the corner. So you can go like this, and Jacob can do this, and then a ring is already there for him to just the intake of his caliber.
Let's wrap up on this robot. Brock, can you talk more about your climb? We were talking earlier, something you have kind of had on, took off, re-implemented again. So talking about how it's working for your team right now.
Yeah, absolutely. So we were kind of in a time crunch for our last competition, so we couldn't really get this working, so we had to take it off, sadly. We did well at that competition, but we didn't do as well as we wanted to. So this competition, we took a little bit of time to remount this hang. So the issue we were having is the hard stop. So what we have here is two zip ties. All these zip ties do is just stop the rotation, and kind of tucked right here we have a rubber band, so it is just a passive activation hang. So it's extremely fast and reliable, and that's all we really need is just something fast last second so we can defend corners or wall stakes, and then the last 5 seconds just hit that hang and have a consistent top ring or 3 points.
Well, pay respects from South Carolina. Thank you so much for taking time to tell us about everything going on. Congrats on your great season so far. I know you got big hopes here at Scores, so we can't wait to see how you do, and good luck throughout the rest of the competition season. Thanks a lot.